Hello guys, my name is Arun and welcome to my channel. This series is a series of tutorials on scientific programming using Python. Now in this tutorial, we will be looking at how to make streamline plots and Quiver plots using Python. Now in the last time, what we saw is that we saw how to make regrid data. This time we'll be looking at how to make streamline plots and all. Okay, the thing is, before I make this, I let me just clean up all the values I have over here. They just populated too much. Okay, and then I need to use the values of u and v, which I've done in the previously, whose values I do not have right here. So let me see if I have the console over. If I have the values over in this console. Yeah, perfect. If you guys notice, in your history log, all the values are available. You can just have you can access them nicely. Okay, copy this, and then in IPython console paste this and press enter. Fine. Okay, and then if you want to access the variables, what you do is that just copy all the functions that some history logs, comments that we used in the history log, like this. Okay, we need these things, so we'll copy all these and then paste them in one shot. It'll take some time. Yeah, and the values are populated, so we're good to go. The values are populated, I'm good to go. Okay, now what I'm going to do is that I'm going to maintain for streamline plots. What I'm going to do is that I'm going to use two variables, um and uv. Okay, what is, it's the mean of all the values in u about axis equals 0. So what this does is that it's going to average all the entries in this three-dimensional matrix u, okay, about x. So all the row if you imagine a three-dimensional matrix, in that assume that all the values in the rows are added to are averaged, so that you get a two-dimensional matrix. Okay, axis equals 0 sets that the average of all of them about the rows is made. So you'll get is actually an average row averaging when axis equals 0. When axis equals 1, np.mean returns your column averages and when axis equals 2, it will return all your level averages, like that. As of now, um and vm are row averages. Okay, so let me copy that, run this, and and vm are row averages. So if you look at the data, you have all the values and ranges over here. So that's good, that's fine. And then I'm going to calculate uv. uv is nothing but just the speed, which is calculated by taking the Pythagorean square root of vector square root of vector magnitude of um and vm. So let me copy this. Okay, these are just for the sake of the example. And now let's streamline plot it. To get a streamline plot, what do you need is that first you have to you need this function called a stream plot, and that does it. That does all the job. Okay, now before that, let's plot them up. So let's plot. Okay, so we have the plot ready. So let's plot the plot the color bar as well. Oh, sorry. It's plt. Plot the color bar as well. So if I plot it, the color bar is also ready. No problem with that. Okay, these are all positive values, so that's how it looks like. So not a problem. And then what I do is that I give the x text, y text, x label, y label, axis, and grid on options and everything. Okay, let me give up to here. So I copy all this. Okay, now if you look at the plot, now the labels are named, the axes are ticked, and you have the grids and everything, so all of this is taken care of, so not a problem. And you can see this is actually a world map, so you can see the continental features like this is continental features clearly. So this is South America. This is like South America. Okay, this is South America, North America. You might see Australia here. This is India. This is Africa. This is the Madagascar island. And if you see this region over here, this is actually Russia and Asia. And you might see a little bit of traces of Europe over, a little bit of traces of Europe over here, a little bit of Africa over here. This is actually a Greenland. Okay, Greenland and some broken island, the Labrador Islands of Canada. I think that's the name. Okay, the topmost part of Canada. This part will be Alaska. This part will be Alaska, and this is your Siberia, the ending portion of Siberia. This might be Japan, I guess. This is Japan. Okay, this is Australia. You can get the feature out of it kind of nicely. Okay, that's about that. Okay, now let's make a streamline plot of it. Now we have the plot. Let's make a streamline plot of it. Now the streamline plot is simple. What you do is that what you need is that streamline plot requires a few things like ln, lat, and bm, and then density 2, line width 2, and color k is used for just making the colors, used for making the lines a little more stark and clear. Okay, so let me copy this up, and if I were to paste this in Spider, okay, this will take time because it's a little intensive computationally. It's a little intensive computationally, so it will take a little time. And once this red button is switched off, it's switched off. It's ready. If you look at it now, this is the plot. Now this plot is heavy kind of, so you can see it just measures all the if you look at it, it takes longitude, latitude, and bm, and correspondingly it measures how the values are. It kind of calculates the values and see how the motions of winds looks like. U is actually velocity along x and y axis. V is actually velocity along y axis along longitudes, whereas this is along latitudes, and U is along latitudes, and so on, like that, east, west, north, south, like that. Okay, that command makes sure that takes all the velocities and sees how the movements look by, and you can also see the arrows indicating that okay, here the winds are taking an anti-clockwise turn and going towards the equator, whereas here the winds are taking a clockwise turn and going towards equator, and then some of them rise up and have some cyclone-like formations over here. Winds over here are very, very weak, and they're like erratic and stuff, and you can see a nice little flow throughout the world from west to east in these regions. Okay, in the topmost part it's kind of messy. Okay, that's how the streamline plot looks like. Okay, now that's how streamline plot looks like. So if I go to Spider again, ln is actually the x-axis, this is your y-axis, your two plots with equal dimension to be done. If you set the density to be less, line width to be less, okay, the number of density will make sure that the number of lines that you give are larger or smaller. Lesser the density, less the number of lines you have. More density, more visible lines. Line width, make sure that the lines have become thicker. The more the value, more thicker the lines are, and everything. And the color is, if you set it to K, all of them will be black. Otherwise, if you just leave it, they may have their own color patterns and everything. Okay, that's about that. And if you want to save the figure, just go about with the similar notation, save fig. Okay, that's about that. And then finally, one more topic called as Quiver. Okay, let me close this up. I don't need this. For Quiver, what you need is that you need a function called as function called as Quiver over here. Okay, it needs longitude, latitude, vm, and it needs a lot of Quiver attributes like pivot, color, units, scale, and everything. Just scale and everything, so that this is proper. Okay, these are proper. Okay, it's going to give an arrow plot. It's just going to give an arrow plot, and that's it. Okay, so this is going to give you this is going to give you plots. So, and this has to be given in terms of q. I mean, q is actually the quiver plots handle, quiver plot handle q. Okay, this q will be used for giving the quiver key at the bottom. Okay, like this. I'll explain how this goes by. So goes by here. These are just for text. So let me copy this. Okay, let me copy this. I'm going to paste this over here. Okay, paste this over here. But thing is, I'm not going to use all of these. So let me just show you how quiver plot looks like without any of these other additional features like scale, units, everything. These are just optional parameters. But if you just look at the quiver plot, this is how it looks like. It's a heavy plot. This is how it kind of looks like, and kind of messy, kind of little hard to comprehend as to what's going on here too. So let me just minimize this. Since there are a lot of points, it may freeze a little, so nothing to worry about that. Okay, now what I do is that let me just close this up. Okay, let me close it. Okay, what I do is that let me copy all this content and paste it over here. Okay, let me set the scale to be 100. Let me scale to be 1000. Let's see how it looks like. Okay, I don't see much difference over here. Now if you put the other axis parameters and everything like plot axis and everything, okay, copy this, I paste it over here. Okay, if you look at the plot is like this. Nothing visually remarkable. Okay, if I give a plot, you can give a plot quiver key like this. That is used for giving the length of the quivers and stuff. Okay, let's see whether this quiver comes out nicely. Minus 330, 75, not much. Doesn't matter. Okay, thing is, let me break this down as to how the quiver comes out. If I set this to be 1000, I'm getting like this. So okay, let me close this up. I'm going to copy all this. But let me set the scale to be 1. If you look at the plot, I just don't understand what is going on. Seriously, I just don't understand what's going on. If I just set this scale to be 100, I'm getting a quiver plot like this. 100 is reasonable, but I don't know if you can see it properly or not. There will be a lot of small arrows here and there. That is what it shows. That is what it kind of shows. Okay, it's a bit messy. And around this region, I don't know whether you can zoom this up. I strictly recommend don't zoom. I don't know whether you can zoom this up and stuff. Let's see. Oh well. Force quit. Actually, what happened is that I think the console died unexpectedly. Okay, you use restart kernel to restart kernel. Yeah, because of that option over there, kernel got stopped. Thing is, this is how we do a quiver plot. Maybe it's because the points are just too many in number. I guess this is how we are getting it. But let's use something simple to do the entire process. I guess I have to import numpy, scipy, and matplotlib again. Import numpy as np, import matplotlib dot py plot as plt. Do I need scipy for this? No, I don't think so. So let me put x equals np dot uh, linspace minus 5 comma 5 with 11 values in between. Now let y be the same. Okay, now let me put x1 comma y1 to be equals np dot mesh grid x comma y. Okay, now let z be equals x1 power 2 plus y1 power 2. Okay, now that's z. Now let's something like b to be, that's one function. Now let b to be x1 power 2 minus y1 power 2, something of that sort. Okay, now let's look at the figures and plot quivers. Okay, now let me plot this. If I were to plot this quiver, q equals plt dot qui quiver, and what I do is that let me plot x comma y comma z comma b. Okay, I plot this. Perfect. Now this is coming nicely. I think it's because the points were just too many in number. The quiver plotting was little hecky. It was not that proper. Okay, now let's copy all this contents over here. X text, Y text, and everything, axis. Okay, copy all this. Let me paste it over here. We need to make corrections to it. Now let x6 be between range minus 5. No, okay, instead of a range, let me put linspace minus 5 comma 5 comma 11, and then same for here. Okay, I think I can put x itself as the argument here, so x itself is the argument here, and I can put y itself as the argument here. Okay, x label just x, y label just y, that's not a problem. Axis, let me set this to minus 5. Okay, let me set this to minus 6. Okay, minus 6 to 6. There's a reason for it, and that this would be minus 6 to 6 as well. And for quiver key, what I'm going to do is that I'm going to place the quiver at x equals 5.5 and y equals minus 5.5. This will be at the lowermost corner, and the value that I'm going to do is, like, let's say 2 meter per second, something of that sort. Okay, now if I were what I do is that let this be as it is. If I plot this up, I should get the value of quiver here, but for some reason I'm not getting it. I mean, this line over here, some of them will have the proper line over here. But anyway, you get the point, right? So let me just plot the quiver key alone. Let me just plot the quiver key alone. I guess let me place this at 6 comma minus 6, whose value is, let's say, 1, and I press enter. Okay, if done nicely, what will happen is that you will get an arrow over here which you can work about with, which you can work about with that. Okay, that's okay, that's not a problem, you can work about with that. Now this is how you get a quiver plot. Now the thing is, with this you can get a quiver plot and streamline plot together as well. Okay, now that is also possible. So for that, what I'm going to do is that let me get you know let me get something called as zb equals z power 2 plus b power 2 whole divided by whole power 0.5. If we look at the streamline plot we did last time, okay, streamline plot we did last time. Okay, let's copy all. Okay, let's copy all this just with little corrections. Let me make corrections. So let this be x be x itself, and y be y itself, and longitude be x, latitude be y, and let this be minus 5, and this be 5, and this be minus 5, and this be 5. Okay, what you'll have is that you'll have a grid ready. You have a grid ready. Now what I'm going to do is that plot stream plot of, you need x, y, u and v, right? So let me put x, y, and z and b. Okay, but the default settings. So if you plot that, you have the streamlines ready, which is quite beautiful and very neat. The streamlines ready, which is quite beautiful and neat. Okay, let this be as it is. Now on the same plot, if I just plot q, if I just plot plt dot quiver, let me plot okay, x comma y comma what do I need for quiver? Let me just check it out. I just need um and vm. Okay, that's not a problem. If I just plot z comma b, okay, now I'll get the plot like this. Beautiful. Yeah, beautiful. If you guys see, they are the quiver plot and streamline plots are coinciding quite nicely. Okay, now this way, now on this, if I were to plot contour f on this, if I were to plot x comma y comma zb, I contour f. Okay, if you look at the plot, okay, this is how the plot looks like, because the color just kind of overruled the plot. That's why you're getting like this. But anyway, you get the point what I'm trying to make here. This is how we create plots, contours and all. And there are other features available over here, like in quiver plot. If you just press Ctrl I, the documentation over here will be available. Okay, available. You can just say what should be the length of the arrows and angles and everything, and all of this will be taken care of. There are like so many options over here, which you just have to check it out on your own, so that everything fits according to your wish and all. Okay, now that's all I have for you guys in this tutorial. Thank you guys for watching, and I'll see you guys next tutorial. And next tutorial, we're ending session 2 of the tutorial series, where we'll be talking about mat files and how to do with mat files and all. Okay, thank you guys for watching, and see you guys next time.